Hi, we're at Embedded World 2024, and I'm just going to give a quick talk on upgrading from FreeRTOS to SAFERTOS. So I'm going to go through some introduction, look at some of the key differences between FreeRTOS and SAFERTOS. We're going to focus on a few specific things like the changes to the object create functions, improved error reporting, and some of the more minor functionality changes. Because SAFERTOS was built from the ground up for safety, we've had to follow a very strict development model. This is our V model. I'm not going to go through all of the details here, but essentially we are starting with high-level requirements up on this side, drilling down to the lower-level requirements, and eventually generating the code. And then we are, based on the left-hand side of the V, creating our test documentation and test code up on the right-hand side. So SAFERTOS is based on the FreeRTOS functional model. Essentially what that means is that it looks very similar to most people as in terms of developing an application using Free or SAFERTOS. So most of the API is going to be either the same or very similar. One of the key differences really is that most people, when they're using FreeRTOS, are using dynamic memory allocation. So they're using the heap. When they're creating tasks, they don't need to pass in any buffers for that task to use. Rather, they are allowing FreeRTOS to allocate it at runtime. In SAFERTOS, because of the safety requirements, everything needs to be allocated at compile time. So all of the tasks you create, queues you create, etc., are going to have to be defined by the application. All of the buffers will have to be passed into the API. SAFERTOS generally does more validity checks of the input parameters, and also the return values for most of the API functions are generally more detailed than those from FreeRTOS. So in FreeRTOS you may return a pass or a fail, whereas in SAFERTOS you are going to get a pass or some kind of specific error code that can give you some kind of detail as to what went wrong. SAFERTOS actually comes pre-certified to whichever safety standard you need to work towards. So for example, a customer working in the automotive space, when they receive the final package from us, will be pre-certified to ISO 26262, meaning that they do not need to retest on their target hardware. So we're going to work closely with our customers to ensure that we're using the same processor, same compiler, and same compiler settings, so that they don't need to do that very time-intensive and costly retesting. So in the final design assurance pack, we actually do give the full source code for SAFERTOS, which can be super useful with understanding what SAFERTOS is trying to do, especially if you're having a problem and you're trying to debug the code. So we're just going to go through some of the changes to some of the API functions. So a nice example is the differences in the task create function. Obviously, this is a function that's going to be used very frequently when you're using either FreeRTOS or SAFERTOS. Immediately as you look at it, it might look like there's less stuff going on in the SAFERTOS task create, but essentially most of these parameters have been captured within this structure, which we're passing a pointer to. So there's actually more parameters for the SAFERTOS task create. So one of the key things that I mentioned earlier, in FreeRTOS, we are passing in the size of the stack for the task. In SAFERTOS, we are still passing in the size, but we're also passing in a pointer to that stack buffer so that the application is supplying the space necessary for that task. There's a kind of similar story for queue create. So there's a few more items here in the SAFERTOS API function. Most notably, we have the queue memory again because of the lack of dynamic memory allocation. And there's also a difference in the return value. So in FreeRTOS, if you successfully create a queue using this API function, then the queue handle is going to be returned from the function. So to check whether you have a valid queue, you just need to check if you have a valid queue handle. In SAFERTOS, we are passing out the queue handle via a pointer from this parameter. So that is actually the same way that both FreeRTOS and SAFERTOS return the task handle. You can see that here. So we're doing that in SAFERTOS to allow us to have a possible return value to the function, some kind of status code. So hopefully PD pass to tell you that you've successfully created the queue, or potentially some specific error code. Because there are multiple different error codes that could be returned, we have to change how we deal with checking for errors in SAFERTOS compared to FreeRTOS. In FreeRTOS, this would be perfectly acceptable, checking whether the queue send failed. Because of the multiple different error return codes in SAFERTOS, we will instead have to check if it did not pass. Another difference is that in SAFERTOS there is an error hook. So SAFERTOS, in many places in its source code, is going to be doing various different checks to see whether there has been a catastrophic error. If there has been an unrecoverable error, worst case scenario, you've got a cosmic ray that hits your device and flips a bit and corrupts some kernel data. If something like that happens, some kind of unrecoverable error, we will call the application-defined error hook. This function is essentially there so that the application can do whatever it needs to do to place the application into a safe state. So because we're a fairly general purpose operating system, we don't know what a safe state is for your particular system. So SAFERTOS is a relatively small RTOS. It doesn't have lots and lots of unnecessary features. We've limited the conditional compilation in SAFERTOS. If you take a look at the FreeRTOS source code, you will see many hash ifs, hash else, that can make it quite difficult to look through the source code. It can make it slightly more difficult to debug through the source code. And generally, conditional compilation is not ideal in a safety scenario. There is very limited conditional compilation in SAFERTOS. If you have to step through any SAFERTOS code, you're going to almost never see any conditionally compiled code. SAFERTOS does not have a coroutine implementation to map, which FreeRTOS does. And there are other differences, such as instead of the FreeRTOS queue sets, SAFERTOS has instead a function called event multiplex. Event multiplex is in some ways more powerful than queue sets. So it allows you to wait for multiple queues, or also wait for event groups or task notifications or other events in the system at the same time. So it is providing a very similar service to queue sets. Some of the minor differences are, for example, in delaying. So in SAFERTOS, we have this SAFERTOS API max delay, slightly different name to what it is in FreeRTOS. But in FreeRTOS, if you put this max delay in for a sort of block time or something like that in an API call, that would mean block forever in FreeRTOS. In SAFERTOS, it means block for this number of ticks, and this number being the maximum value of an integer. So that, because it's in ticks, is going to depend on your application tick rate. If your tick rate is similar to sort of 1,000 hertz or something like that, then you will find that this will block for sort of 1 to 2 months of real time. Everything that I've gone through here and more is covered in detail in our application note, upgrading from FreeRTOS to SAFERTOS. This is freely available on our website, so if you go into highintegritysystems.com, you can find it quite easily, as well as many different free web demos. So these web demos we have for many of our supported processors and architectures, and they have a time-limited library of SAFERTOS with a demo application, so that you can try out SAFERTOS for free with no obligations. Thank you very much.